Health benefits of peptides. TIANJIU TIANMEI Biotechnology Company. What are peptides? Peptides are derived from proteins. Basic unit of proteins are amino acids. When two or more amino acids are linked together, they form what we call peptides. Proteins are broken down to peptides during digestion, and peptides are finally broken down to amino acids. Introduction to bioactive peptides. Peptides are a good source of amino acids for the development of muscles, enzymes in the body, hormones, and other protein structures of the body. Polypeptides can show independent activity not shown by original proteins because by their lower molecular weight, they can bind to receptors in the body to elicit a different physiological activity. Little amount is needed to bind to receptors to express physiologic function. Because they are smaller in size to the main protein, therefore they can bind to a different receptor and elicit a different activity. Physiological activity of peptides may involve hormonal regulation, enzyme blockage, and neurotransmission. Examples of bioactive peptides that we have: wheat peptides, which ease pain and regulate nerves. Compeptides is an angiotensin enzyme inhibitor. It regulates blood pressure, protects the kidney, and improves insulin sensitivity. Compeptide is also a sober-up peptide or nerve-calming peptide. Soya bean peptide also lowers blood cholesterol. We have walnut peptides that improve memory. Albumin peptides are powerful antioxidants and immune boosters. Collagen peptides regulate the release of pituitary hormone, and also they are very good for skin and beauty. Oyster peptide have a lot of zinc binding peptides. It's good for memory and beauty. Then skin cucumber peptides is good for skin beauty. Let's look at how peptides are classified based on their health benefit, that is health classification of peptides. We have 6 that we have classified. The first group is antihypertensive peptides. Second one is antidiabetic peptides. Third one is cholesterol lowering peptides. The fourth one, memory enhancing and nervous peptides. Then beauty and skin peptide. And the last one, which is the 6th one, is immune boosting peptides. Let's look at antihypertensive food-derived peptides first. Mechanism of action of antihypertensive peptides. Certain peptides have the ability to modulate renin-angiotensin RAS system because they decrease activity of renin or angiotensin converting enzymes. These two enzymes regulate mammalian blood pressure. These antihypertensive peptides can also enhance endothelial nitric oxide synthase (ENOS) pathway to increase nitric oxide level within the vascular wall, thereby promoting vasodilatations. That is the second way peptides act to regulate blood pressure in the body. Also, the peptide can block interaction between angiotensin II and angiotensin receptors, which can contribute to reduced blood pressure. The third way these peptides act to control blood pressure is through opioid receptors that are present in central nervous system, and they are involved in the regulation of blood pressure through increasing activity of the sympathetic nervous system. Peptides can reduce blood pressure by binding to these opioid receptors. Bradykinin is a natural peptide in the body that causes arterioles to dilate, enlarge via the release of prostacyclin, nitric oxide, and endothelium hyperpolarizing factor. Also, another innate or natural body peptide is atrial natriuretic peptide (AMP) and B-type natriuretic peptide. They both act at many sites in the kidney and elsewhere to decrease left arterial pressure and blood pressure and increase renal salt excretion, which further lowers the blood pressure. Also, we know that the antihypertensive drug aliskiren is a peptide, though synthetic peptide, and is renin-like inhibitor, and unlike most, it is rather hydrophobic. It blocks catalytic function of enzymes, the angiotensin converting enzyme. Now, what we are saying is that any peptide from our food that is extracted that acts in this manner of these natural peptides can also lower the blood pressure. And let's look at examples of our own antihypertensive peptides, that is corn oligopeptides. It is an angiotensin enzyme inhibitor, ACI. It prevents the kidney enzyme from producing angiotensin 2, which is a vasoconstrictor that causes the blood pressure to be reduced. Actually, angiotensin 2 is a high blood pressure agent, that is, it causes hypertension. Then it causes insulin resistance, that is diabetes, and can cause kidney damage. So when you take corn peptides and it blocks the action of angiotensin enzyme to produce angiotensin 2, you naturally reduce the blood pressure, also reverse diabetes, and at the same time you protect the kidney from being damaged. It also calms nerves. It prevents alcohol toxicity, that is, it is hepatoprotective. It protects the kidney from damage from alcohol. It reduces blood cholesterol, that is, it reduces hypercholesteremia, excess cholesterol in the body, and it helps your body also to recover quickly post-traumatically. Now let's go to anti-diabetic peptides. Let's look at the way they act, mechanism of action. The hypoglycemic hormone in the body, insulin, is a protein. So it is not surprising that in some of our natural foods, we have peptides with blood sugar lowering activity, that is insulin-like activity. Physiologic peptides like amylase, alpha-glucosidase, glucagon-like peptides, and dipeptidase 4 have effect on blood sugar. So any peptide that can modify the effect of this natural peptide will have effect on blood sugar, that is lowering of blood sugar. Incretin glucagon-like peptide 1, GLP-1, can activate gastrointestinal reflexes that control gastric motility, thereby slowing gastric empty. There are synthetic drugs that have been modeled after this action, but here we're talking about natural products, that is peptides. Simultaneously, GLP-1 acts as hormone at the isolate of Langerhans in the endocrine pancreas to stimulate release of insulin, while suppressing the release of glucagon. This immediate and multiple actions of GLP-1 reduces fluctuation of blood glucose after food. The actions of proteins and peptides mentioned above can have significant effects on blood pressure. Therefore, it is not surprising we see blood sugar lowering activity in peptides obtained from our food that are under block or imitate the action of the peptides that have control over blood sugar in the body. Let's look at examples of antidiabetic peptides. The great one is wheat peptides. This is surprising because there is an history of diabetes and wheat. Gluten, a protein from wheat, has been known to cause insulin resistance, hence diabetes. It also causes autoimmune disease of gastrointestinal tract called bowel inflammatory disease. These days, peptides have been extracted from wheat that have opposite anti-diabetic effect. So from wheat now, we have peptides that actually counter the negative action of wheat. Let's look at wheat oligopeptides. Oligomethionine peptide present in wheat peptide can stimulate insulin production in diabetic, regulating blood glucose. It inhibits angiotensin converting enzyme, thereby reducing blood pressure. It protects the kidney and improves insulin sensitivity. It also contains opium morphine-like substances called endorphins, which regulate nerve conductions and promote neuroregulation. It has analgesic, pain-relieving activity and also euphoric or mood-stimulating effect. It also boosts immunity by stimulating lymphocyte production and phagocytic ability of macrophages. It stimulates intestinal immunity. Now, the third class of peptides are the hypolipidemic peptides. Let's look at their mechanism of action. We all know that high-density lipoprotein, HDL, is a protein in the blood that mediates reverse cholesterol transport, thereby lowering blood cholesterol and preventing atherosclerosis. Peptides that can mimic the action of HDL can be produced from our foods. That's one way in which these peptides act. They mimic the action of HDL. So they help reverse cholesterol transport, lowering blood cholesterol. The second way they can act is also they act as bile-acid binding peptides. They decrease micellar solubility and inhibit cholesterol absorption. This will have significant impact on the level of cholesterol in the blood. So example of peptides that are hypolipidemic in nature are soya bean peptide and mung bean peptides. So let's look at soya bean peptides. Soy bioactive peptides that have a variety of physiological functions such as hypolipidemic, antihypertensive, and anti-cancer properties, and anti-inflammatory, antioxidant, and immunomodulating effect have been identified. Some soy peptides like lunacin and soy morphines possesses more than one of these properties, and they play a role in prevention of multiple chronic diseases. The dietary bile acid binding proteins included in soybean protein and its peptides are effective in ameliorating hypercholesterolemia. Soybean peptide promotes nitrogen balance and muscle formation, thereby eliminating fatigue. It lowers blood pressure, protects the kidney, and improves insulin sensitivity, like I've said above. It lowers blood cholesterol, that is hypocholesteromic in nature. It promotes body metabolism, thereby eliminating subcutaneous fat. It eliminates lipid peroxidation by free radicals. It increases emission of alcohol from the body, and as we have said, is useful in diabetes, and also it boosts immunity. Let's look at mung bean extract, the nutritional benefit to you. Mung bean peptides is useful in treatment of hypercholesterolemia and intestinal detoxification. It helps in chelation and removal of toxic heavy metals like lead, aluminum, mercury. So it helps to detoxify your body. Now, the fourth kind of peptide we have a memory and nervous peptide, that is memory enhancing peptides. How do these things work on the brain? That is the peptides. Endorphins are opioid or morphine-like protein in the body with analgesic and euphoric or mood-elevating effect. So peptides with similar structure can have similar action. That is the first way they might act. Then we also know that amylin and amylin receptors have a role in the pathogenesis of Alzheimer's diseases and other neurological diseases like multiple sclerosis and Parkinson's disease. One of the defining features of AD, that is Alzheimer's disease, is the presence of soluble oligomers of amyloid beta, AR beta proteins that aggregate into extracellular fibrillar deposit known as amyloid plaques. Progressive accumulation of intra and extracellular alpha beta proteins within brain regions that are critical for memory and cognitive function is linked to the neurodegeneration observed in Alzheimer's disease. So peptides that inhibit the action of amylin in the brain, we have memory preserving and neuroprotective functions. A major example of memory and nervous peptide is walnut peptides. Let's look at walnut peptide. It helps in developing excellent intelligent quotient and prevent memory loss. It is neuroprotective. Walnut peptide has a good brain effect. Walnut peptide has assistance to improve memory. Walnut peptide has the anti-fatigue capability. Walnut pepper has antioxidant capacity, and walnut peptide has blood pressure lowering effect. Now let's go to the fifth kind of peptides, the role of peptides in skincare, that is the skincare peptides. Let's look at them. How do peptides care for skin? Mechanism of action of beauty and skin peptides. Peptides are the building block of collagen and elastin fibers that are found in the skin. They are the main protein that make our skin firm and beautiful. When you take these peptides, they can stimulate production of more collagen and skin proteins. They also inhibit collagenesis and elastase enzyme that break down collagen and elastin in your skin. Peptides can help reduce the appearance of fine lines and wrinkles. Let's look at the example of skin and beauty peptides. Pea peptides, collagen peptides, oyster peptides, and sea cucumber peptides are a good example of skin and beauty peptides. Let's look at pea peptides. Pea peptide is good for skin beauty by inhibiting skin elastase, thereby protecting skin protein called elastin, and it also regulates blood pressure. Pea peptides are long chain of amino acid which form part of pea protein. Pea peptides can help stimulate and strengthen follicle stem cells, which help to promote hair growth and prevent hair loss. That is, it prevents baldness or alopecia. Let's look at collagen peptides. Collagen is a major component of your skin. It plays a role in strengthening skin and may benefit elasticity and hydration. Several studies have shown that collagen peptides or supplements containing collagen may help slow the aging of your skin by reducing wrinkles and dryness. It also promotes bone strength and skin beauty. Let's look at oyster peptides. Oyster contains large quantity of zinc and is useful in children memory and beauty. It also contains high quantity of arginine, makes it useful for sperm production. So in patients with low sperm count, is useful. Skin is also good for, zinc, the content of the peptide is also good for other functions of the body, like raising the body metabolism, is good for your intestinal function, that is good absorption of food, and it's also good for your eyesight. So zinc has been known to be useful in all these physiological conditions. So oyster peptide actually helps these areas in the body. It also prevents arteriosclerosis. Let's look at sea cucumber peptides. The sea cucumber body wall is about 70% of collagen protein. So it is a source of biologically active peptide. It has skin beauty and anti-aging properties. Now lastly, let's look at immune boosting peptides. We are looking at immunity here. Let's look at mechanism of action. We already know that antibodies in the body, that is the immunoglobulins and cytokines from the immune mediators, are proteins, and they mediate immunity. So peptides have been known to increase the ability of the body to produce more immune cells, like the neutrophils, the lymphocytes, and also produce more protein mediators like the antibodies and the cytokines that are useful in immune mediation. Examples of immune boosting peptide is the albumin peptides. Let's look at albumin peptides. Albumin peptide is a good source of essential amino acid and boosts immunity, and they have powerful immune boosting capability, raising CD4 count significantly. Which CD4 count shows you that we have a lot of helper T cells that can help both the humoral and cell-mediated immunity to respond significantly to infection. Thank you and God bless. But before I leave, I want you to know that all these peptides we categorize are not totally restrictive to those classifications. Some of them have multiple functions that make them to fit into several groups, but we just put them in those classes so that it can be easy for you to understand and follow. So that is the end of this presentation on the health benefit of peptide. Thank you and God bless you.